Hi, this is Lynn Turback, and I'm going to go over an example of divide, conquer, glue problem solving in BuggleWorld. The slides I'm using here can be found on the CS111 schedule page in the Friday, February 8th date. Okay, suppose I asked you to make the following two designs, Design 1 and Design 2, in BuggleWorld. Well, immediately you would notice that there are some similar components here. So much of computer science is trying to find what the patterns are. And in the BuggleWorld, we're often searching for visual patterns. So here are some examples of the visual patterns that we see in these designs. For example, we have, in each case, we have 4 nested boxes with alternating colors. So let's take this example here. What do we have? We have a side length of 8, and we have colors that alternate between red and blue. In this example, we also have a side length of 8 and colors that alternate between blue and red. In this example, we have a side length of 12, colors alternating between magenta and cyan. In this case, we also have a side length of 12, but alternating between cyan and magenta. And in this case, we have 4 nested boxes, starting with a side length 16 and alternating between black and yellow. So what I'd like to do is we'd like to capture the common designs that we're seeing, or common components of the designs that we're seeing, in a method. And here's one way that we could capture these. So imagine that in addition to capturing the side length and the 2 alternating colors, we're also capturing the starting point of the nested boxes relative to the original position of the bugle. And this is not strictly required, but it turns out that this is going to help us to glue together the pieces later on. So for instance, let's imagine that our bugle is, in the left case, is over here, and he wants to draw this particular box. Well, to do so, he would have to move forward 1 unit and jaunt to the left here by 2 units, but then assuming facing in this direction, the bugle would then draw a nested box pattern alternating between blue and yellow of side length 8. And so that's captured here by these 5 parameters to this nested boxes method, which doesn't exist. We're just imagining that it exists. This is something called wishful thinking. Wishful thinking says, gosh, wouldn't it be nice to have this particular nested boxes method? Then we flesh out the details of its contract, and then we go off and we use it to implement stuff. So here's example number 2 over here. This is similar, except that in this case we travel 1, 2, 3, 4 spaces forward. We jaunt 3 to the left, and then if we were facing in this direction, we would be going off and drawing a nested box pattern of length 12. So this is length 12, and alternating between magenta and black. So if in fact nested boxes did exist, this is what we would do in these particular cases. Okay, so now let's talk about making a contract for the nested boxes method. So as part of wishful thinking, we make a contract for nested boxes that formalizes what the nested boxes method is supposed to do for a living. So let's take a look at this contract. We find that it is a void method, and that means it doesn't return anything. We will study methods that return things shortly, but we haven't seen any methods that we define that return things yet. The name of this method is nested boxes, and it's going to take 5 parameters. First is an integer that says how much it goes forward, an integer that says how much to the left it's going to go, an integer that is the side length of the outer side of the 4 boxes, and then 2 colors that we're going to call C1 and C2. And we use these names within the contract. Now the main thing that we specify here in the contract is that, of course, this method will draw 4 nested boxes with outermost side length outer side, alternating between colors C1 and C2. So that's pretty clear. That uses the last 3 arguments, formal parameters of this method. We also specify this part, and again, this part isn't strictly required. If you were designing this on your own, you might not put this part in, but we'll see how useful this part is. So we're also going to specify that the starting corner of the outermost box is at a location forward units forward and LT units to the left of the buggle's current position. And then we're imagining that when the bugle starts drawing, it's still drawing in the same heading that it was originally facing. That is, this movement forward and left does not cause the bugle's orientation to change, it just moves the position of the bugle. And we'll say more about that later. We should also say what happens to the bugle at the end. This is very important in any bugle method. So here we state that two things. One is that the bugle's final position and heading are the same as its initial position and heading. And anytime that things don't change, we say that they are invariant. So in this case, we say that the bugle's position and heading are invariant. And invariant things, keeping things invariant is actually very important. We'll have more to say about this later in this example. In this particular case, we're going to assume that we can change the brush state and color, so that just for simplicity now, we'll assume the final brush state is down and the final color is C2. And those are details that are kind of arbitrary, and later on we'll see how we can improve them and make them better. But for now, let's assume that basically if we're assuming that the bugle is drawing from the outer to the inner rings, that we'll let its brush state be down and the final color be the color of its innermost ring. Okay, so that's a contract. Now we haven't written anything yet, right? We're just imagining that nested boxes exist because by wishful thinking, it's a useful thing to have. And now we're going to do some nice problem solving here, where assuming that this nested boxes method exists, even though we haven't defined it yet, assuming that it exists, let's go off and completely design a solution to this design one here using only 5 calls to nested boxes. And what I want you to do now is I want you to stop this screencast and then write down on a piece of paper what the arguments to the 5 calls to nested boxes would be in order to create the design that you see at the upper right. And when you've done that, restart the screencast and we'll take a look at a solution. Okay, here are the solutions to the design one. Now, the order in which we call the nested boxes actually matters. So notice that things that we call first will effectively be on the bottom. So that, in fact, we want our 2 designs here in the lower left and upper right. Those must be done first. The order that they're done in is irrelevant, but they must be done before the other ones. So those are these 2 calls to nested boxes. Let's assume the one in the lower left is first. In this case, we do not have to move the bugle at all. It's already in the lower left corner. So we move it forward 0 to the left 0. Side length is 8, and it's alternating between red and blue. And then the other one, if we count up, it is 16 units forward and 16 units up to be starting over here, facing in this direction. So we have a change of 16, 16, forward and left. It also is a side length of 8, and it's alternating between blue and red. Next, you'll notice we have to have the yellow and black nested boxes. And to get to the starting point, which is right here, we have to go forward 4 and up 4. So that's where the 4, 4 comes from. It's of side length 16, and the colors are alternating between black and yellow. And finally, the 4th and 5th ones, again, the order doesn't matter, but they're on top. Let's assume we first do the one that's over here in the lower right. We're going to go forward 12 units. We're not going to go to the left at all. And this is a box of side length 12, alternating between magenta and cyan. The other one, we do not go forward at all. We, in fact, move to this position, which is 0 forward, 12 to the left. It's also side length 12. And alternating between cyan and magenta. Okay, and one thing to notice here is that because we have baked in the forward and left parameters, there's no glue that's needed between these different parts, because each of the nested boxes ends with the bugle in the same place where it started, and the forward and left are automatically baked in. And if we didn't put the forward and left as part of the parameters to nested boxes, then we would need extra code to glue these parts together. And that wouldn't be terrible, but we would need extra code. And so one of the nice things about the design of this particular pattern is that we have baked in the glue between the different parts so that it's not necessary to specify extra glue other than just calling nested boxes. Okay, now what I'd like you to do now is, just as a second example, methods are useful to the extent that they can do multiple problems, and let's just show that we can solve this problem using the same nested boxes method that we used before. So again, I want you to figure out what parameters you can supply to nested boxes to solve this problem. Turn the screencast off, do that, and then turn the screencast off, or turn the screencast back on when you're ready for that. Okay, here are the solutions for design 2. There are 4 boxes in the background and 1 in the front. The front one being the yellow and black one. The 4 ones in the background must be drawn first. They can be drawn in any order. We'll happen to start with the one in the lower left corner, which is at coordinate 0, 0, side length of 12, alternating between red and blue. Then we'll go the one that's in the upper left corner. That's coordinates 0 and 12, side length of 12, alternating between cyan and magenta. Then we'll go to the one in the upper right, which is at coordinate 12, 12, side length of 12, alternating between blue and red. And then comes the one in the lower right corner at coordinates 12, 0, relative to the bugle. Then there's side length of 12, magenta, cyan. And finally, the yellow and black one is at coordinates 4, 4, side length 16, with colors black and yellow. That concludes our first Divide, Conquer, Glue screencast. In the next one, we'll look at how to implement the nested boxes method.